What I would like to talk about in the next couple of slides is how supply and demand changes. What does it mean supply to be decreasing or increasing, and what does it mean for demand to be increasing and decreasing? So what you can see here is two graphs, one titled supply decrease and the other titled supply increase. And what can we see here? Well, first of all, we need to remember which one is the supply and which one is the demand curves. Well, demand is what the market wants, what the shopper wants. Obviously, if prices are going up, demand will go down. So high price products I don't really want to buy. And supply is the production, supply is the company. So for them, if price is really small, they don't really want to produce a lot. For them, if the price is higher, then they will be willing to produce more because that's going to mean them a lot more profit. So in these graphs, the downward sloping graph is always the demand, and the supply is the other way around, is the upwards going graph, because as quantity goes up, price goes up. So what you can see here is two different supply and one demand curve. Now, let's look at E1, which is equilibrium 1. In equilibrium 1, we have got Q1 quantity sold at P1 price. Now, what happens if we compare this with equilibrium 2? Well, in equilibrium 2, the quantity is Q2 is smaller than Q1, but price 2 is bigger than price 1. So what actually happened in here? Well, contrary to common sense, we can say that supply decreased. Also, supply seemingly went up because this equilibrium 2 supply is higher up than equilibrium 1 supply. When you look at the quantity is dropped, Q gone smaller. Therefore, this is why we call it supply decrease. And that's why we call it a left shift, because as quantity goes to the left, that's how quantity decreases. In the other graph, which is titled supply increase, when we look at E1 and E2, we can again find that for E1 I have got Q1 and P1, and for E2 I've got Q2 and P2. But what happened here to the quantity? From equilibrium 1 to equilibrium 2, the quantity increased. So although seemingly the supply went down as the graph itself, if you look at the quantity has increased. So that's why you call it a supply increase, and that's why it's named a right shift, because quantity in the right direction is growing. It's getting bigger and bigger. Now, when we look at the demand shifts, again, you can see two different graphs here. One of them being called demand increases, the other ones being called demand decreases. Well, the setup is similar, but in the previous slide we kept demand fixed, but now we're keeping supply fixed. So we got a fixed supply, and then we're looking at how the demand changes compared to that fixed supply. So in the demand increases graph, we again have got equilibrium 1 and equilibrium 2. In equilibrium 1, we got the corresponding quantity 1 and price 1. And in equilibrium 2, we've got the corresponding quantity 2 and price 2. So what's actually happening in here? Well, demand has gone up because the quantity demanded, Q1, has become now Q2, which is bigger than Q1. And in this scenario, we probably can see it more intuitively because the graphs are now changing in the expected way, in a sense. So when you say increase, demand increases, you see that demand goes up, the graph itself. However, what's important in here is that we have got a right shift, so your Q is changing in the positive direction. And when you look at the demand decreases graph, it's the other way around. So if you look at equilibrium 1 with the corresponding Q1 and P1, well, I can see that compared to that, equilibrium 2 has got a smaller quantity, also a smaller price, but that doesn't really tell us anything about the change. So in this particular case, demand decreased because the later demand Q2 is smaller than the original demand of Q1. And again, these graphs are seemingly changing the expected way, but don't forget that here is the change, the increase and decrease is always compared to quantity. So that's how we got a left shift. So quantity changes into the negative direction. That's why this is called decrease. Now, we talked about supply and demand changes, but now let's see how we can actually plot these supplies and demands. So let's say that I have got the Q equals minus 20 plus 4p as one of my functions, and the other functions would be Q equals 30 minus 5p. So how can I plot them? Well, plotting linear graphs is very simple because I can just choose p to be 0 and calculate q, and I can choose q to be 0 and calculate p. Now if p is 0, that part disappears, and therefore q will be minus 20. And if q is 0, I need to do some calculations. So 0 equals minus 20 plus 4p. I'm going to move the minus 20 to the other side to make it positive. So 20 equals 4p. And now I need to divide them by 4 both sides. So then p will give me 5. So I've got the points I wanted for the first graph. For the second graph, if p is 0, q will be 30. You remember that part disappears because 5 times 0 is 0. And if q is 0, I need to do the calculation. 0 equals 30 minus 5p. Now I want to move negative 5p to the other side, so that becomes positive. 5p equals 30, and then I can divide them by 5 both sides to get to p, which will be 6. Now I've got the points that I want now, but how am I going to draw them? Well, let's do it on our next page. So what I've done now, I've drawn the coordinate system, and notice that I've drawn a much longer line on the negative side because I spotted that q in one of them has to be negative 20. And I've drawn the two lines in separate colors so we can distinguish them a little bit easier. So first of all, I need to come up with some sort of scale that is good enough for me to draw minus 20 as well as positive 30. Well, I've got quite a lot of space in here, so maybe I can go up in 5s. So 5, 10, 15, 20, 25, 30. Then I can go minus 5, minus 10, minus 15, minus 20. And on the y, on the p direction, I just need 5 and 6. So that's going to be quite easy. 1, 2, 3, 4, 5, 6. Right, let's start with the blue. If p is 0, q is minus 20, so I am here. If q is 0, p is 5, so I am here. So what I need to do now, draw the line, and that is my first line. Let's look at the other one. If p is 0, q is 30. And if q is 0, p is 6. And again, what I need to do is just draw a line connecting the two of them. Now, what's important about this graph, that in reality, Although I very much needed this point to be able to draw the graph itself, this is not part of my curve because I don't have negative quantities. Okay? Now, the next thing. Which one is the supply and which one is the demand? Well, remember, suppliers, companies, are willing to produce more if the price is higher. So as P goes up, Q goes up. So that is the upward going graph. That is the blue graph. So this is my supply. And obviously the other one has to be the demand. But again, just think about it. As price goes down, buyers are going to buy more and more of the product. So that's how demand works. The cheaper the product, the more you can sell. And here is the important point, which is the optimal point or the equilibrium. And it's also called the optimal point because it's the optimal situation. This is when everybody is happy. Suppliers are willing to produce product at this price, and the market is happy to buy it. Now, there are two possibilities here. If I draw the graph correctly, I can read off the coordinates. Just going across and coming down. But if you don't trust your drawing skills, you can always solve the equation. And basically, you would need to solve the minus 20 plus 4p and the q equals 30 minus 5p simultaneous equation. And again, if you're not sure how to solve systems of linear equations, just go to the Khan Academy website and check out the link.